So first we will start with Shapiro reaction. So this is very easy reactions. Uh, so let's me write the reagent reactant first. In general, I am representing R. This is NH, and this is H double bond O, H double bond O here. So this is nothing but the hydrazone. So this is C double bond O hydrazone of aryl sulfonate. So this is hydrazone of what? Aryl sulfonate. First, I will discuss in details with mechanistic view. Then I will show in short how to do that and what is the importance of this reaction. So if we treat these molecules by two equivalent butyl lithium, then what will happen? One equivalent butyl lithium will deprotonate this NH. So what will happen? So first the deprotonation from this NH N minus, it is H double bond O, and yeah, so this is stable because it can delocalize into this sulfur. Then the next point of view are dust and R. Secondary protonation will happen from the same side as that of this aryl sulfonate group. That's why secondary protonation will happen here. So it is same side syn to aryl sulfonate group. Syn to aryl sulfonate. So this is the key point of this reactions. So why this is secondary process happens here in details I'm not going to show. At last I will show for others reaction that why it is happening from this side. So this is the key point here. This is a very important step, secondary protonations. After that, what will happen? Then this kind of phenomenon will happen and it is delocalized and it will leave. As a result, we will have these things now. This is double bond R, this is R dashed N, double bond N, now it is minus and we will have lithium plus. Sorry, lithium plus. Later, what will happen? So nitrogen is a good living group. Then as a result, we'll have these things. This is minus or Li plus we can write. Sorry, this is R and this is R dash. So this is the thing we have now after deprotonation. So if we treat with the electrophile, we are going to get these things. Double bond. Now it is E is here. R dash. So what we are getting there, here we get the less substituted alkene. So that's the beauty of these reactions. Less substituted alkene. Now might in this situation you might this quite complex. Just wait for a couple of minutes. You will see that in a second you can answer it for the questions. Less substituted alkene. To gain your interest, to make it not boring, just I am discussing in very details. So here just being as a chemist, I have to add something. As we are using butyl lithium, we should use the solvent like THF, and we have to maintain the temperature minus 78 degrees centigrade. Just for technical purpose, I am writing it. For exam purpose, you don't need that. So this is the key point, and this is the key point. Less substituted alkene will be produced there. So this is Shapiro reactions. So what is how do you know? So this is the upon treatment with this aryl sulfonate hydrazone with 2-butyl lithium, and this is the things. Now, just I'm coming to the direct examples. So if we have this substrate, this is example one. I showed around 10 type of examples. Example one, if we have these derivatives, so this is hydrazone. Hydrazone can be given in direct form, or it can be it can ask you to synthesize these things. So this is pH and this one. So let's proceed by mechanistic way. So first, I would treat with 1-butyl lithium. I am doing step by step. Now it will double bond N. This is N minus and this is TS. So this is pH. Second step, again butyl lithium. you understand that this group will be is given, like this group is oriented in this manner, it outward. So if it is not given outward, then what we will do? Let's say it is not given in this manner. So let's think it is given this one plus NH2 NHTS. Then how do you know it is outward or inward? Then we have two options where we will do it. This double bond N, we can put this NH outside and pH, and we have another possibilities that we can do easily. This is NHTS. Now see, it is sterically unfavorable. That's why this is the option. So this is outward direction. Okay. And second trick is here that the deprotonation will happen from the same side. So deprotonation will happen from this carbon because it is projected this side. Then second step we will have, this is N minus TS. This is minus. So this is the second step, which is the key step of these reactions. Then what is given? If it is these things, then ultimately this is going to be this form. So we'll have this one, and this is Li plus. That is the minus is here, pH. So just here I didn't show the mechanistic details. Now if you treat these molecules with D2O, D incorporation will happen here. So this is D pH. So this is the product. Look, we have got less substituted alkene. Less substituted alkene. These reactions you will get in the book of Carothers. Maybe this kind of detailed step is not given, but that book contain the direct product, but you can easily understand. Normally, we are habituated always with the more substituted alkene. By this reaction, we can get less substituted alkene. So, what is the tricks? The tricks is that basically it's not about tricks. It's very much straightforward. NHTS. Then what we will do? Just after a couple of steps, we are going to have these things. These sides, this carbon, this double bond. So this double bond followed by lithium. So this is the step we have. Then it will attack by electrophile. So now you might, this reaction is very much easy. You definitely think this reaction is very much easier. Now you see, directly this question was asked in GATE 2011. Directly this question. Later I will some again more questions. So this is one important one. If you don't know this reaction, it might happen, is very much complex, but indeed this is very easy. You can solve this question within 30 seconds. Okay. Now you have to be habituated with different kind of group. So it is example 2. Similarly, it is hydrazone and sorry. If you look for a good rank in competitive exam, you never should opt out these reactions. So two equivalent butyl lithium. If you do that, we know that first will happen here and second will happen here. So as a result, what we are going to get, this is N, this is N minus, this is H double bond O, and this group is called TRISYL. In short, I wrote it. So secondary potential is here. As a result, what we will get here, now I have added another things. This one. Okay, this is the iodide one. It's very interesting. And I have changed the reaction conditions. Even it is, I told that if you use butyl lithium, we have to maintain minus 78 degrees centigrade temperature around, or minus 60 to 70, around minus 60 to minus 70. I am adding this in this low temperature. Then what will happen? This will make a nucleophilic attack here. Once this make a nucleophilic attack here, so this group is going to attach with this. So what we are getting? N, we have N minus. So we have freeze this molecule at Shapiro condition. So this is now we have new bond here. So this is the new bond, and as usual we have these groups and OM. Now I have added again one butyl lithium. Then deportation will happen from this sides. As a result, this double bond O, sorry, this is double bond N, this is N minus, this is double bond O, and this is I write. So why I write these two? So if it's given T R Y L, you should not be confused. This is the same group. That's why I write the both versions. And here we have these things now. And this is OME. Now this is minus. We know that. So this is now the condition of Shapiro conditions. It is, and once the temperature is 0 degrees centigrade, then we know that here we'll have a double bond. OME, we have double bond here, and what we'll have a lithium. That is minus is here. Just to try with some different iodide. So you can try with, let's say you have given I2, then iodination will happen here. This is OME and I. So this is the product we are going to have. These reactions we can find in the book of again Carothers. First, I am just covering all the example from Carothers. Then I will move to the journal. Okay. So I hope you have got this example. Basically, what I'm trying to do is just I'm elaborating the reaction or exaggerating the reaction to different conditions. The main thing is same. Sometimes I am just using one more thing here. Sometimes I using different nucleophile here. That is, I tried to cover the reaction from 360-degree background so that the question can be never missed from here. And what I am doing here, the mechanistic path is not shown in that book. I am adding the mechanistic path here so that you no need to memorize it. If you want to memorize the organic reaction, you have to memorize more than millions of reactions. So it's beyond our control. So it is better to learn the reactions. And if you learn the reaction, we can solve it very quickly. And yeah, so this is the example here. This is double bond N, this is NH and TRISL SY. It means it is that group. And we have this group here. This is this one. So NH is in that side. So if we add two equivalent butyl lithium, first what will happen? Here I know that this is the double bond here, lithium will come and this will be here because NH is projected that sides. Its bent is this side, so it will be here. So these ones, I know I have a lithium here. Lithium means it is plus and this is the minus. And I have these things. Then what will happen? This negative charge will attack here and it will just expose and catch on lithium. So we have now these things. CH2 and this is the lithium here. Okay. Then if you add one E plus, then again lithium means I told that it is minus, this is plus, so this minus will catch the electrophile and it will be E. Another twist is here, if E is equal to DMF, DMF is a formulating agent, means NN dimethyl formamide. So this is C double bond O H. This is methyl, this is methyl. It's a formulating agent. Formulating agent, DMF. So if E is DMF, let's think that something nucleophilic attack is here. Just try to understand. So this is not so easy here, but let's say one nucleophile. Then what will happen? It will attack this carbonyl carbon and it will leave. It's happening in quite complicated manner, but just to understand, I'm showing it. So it transferred the formyl group to the nucleophile. So here, if E is equal to DMF, which E plus is equal to DMF, we are going to get this one aldehyde. So here we have CHO. So we can also incorporate a formyl group based on this. So this is another aspect of these reactions. It's very interesting reactions. Next, I will show in CSIT the question came from this formylation part. Okay. Here I am coming and I will explain in this form. For example, we have just have a good practice with this group, just hydrogen group. And instead of hydrogen, if we have this ring, then you may get confused in exam. Then what to do if this is the ring? So this ring is called aziridine ring. Okay, aziridine ring. So first I have shown you that every reaction by this kind of ring, but here I have changed the substituent to aziridine. If it is aziridine, it is the same thing. For this reaction, just I want to say here we use 0.1 equivalent LDA. Why I had 1 equivalent LDA? I am telling that these are precise examples. Normally, what I taught you up to this, I have always used two equivalent base. First to deprotonate on N minus here, or NHC. I don't have any NH here. So I don't need one equivalent. And just to deprotonate these things. But here, as a byproduct, and after the reaction, we have LDA regenerated. That's why it is 0.0 equivalent. But this is a Shapiro conditions. So here we will have this thing. So Shapiro means we'll have double bond here. So directly I am writing the product. So to give you these informations, just don't get confused if it is given a aziridine ring and it is even 0.1 equivalents. Okay, now here I am trying to show you the why the deprotonation, second deprotonation form from the syn site. So second deprotonations occurs from syn to aziridine ring, or you can compare with or previous example also. So let's come here. I'm just showing you why R and R test. So let's say this is the R1, this is R2, this is double bond N, and this is pH. We have used LDA. If I use LDA, then that only deprotonation side is this one. So it will be negative as a result. So you just read it, see it very carefully. It is not given in any of the book. You say Carothers, you say Carrion Sandberg, you say Clayton, none where it is there. Just to gain your interest, I have added this point here. So it is the agitated ring, pH. Now this is minus and this is lithium plus. Here we have some chelation. This chelation helps the deprotonation from the same side. This chelation enhance or helps the second deprotonation from the same side. From same side. So now you understand why second deprotonation is here. Okay, so this is the example that I showed you before, except this agitated one, it is was in some different book. Now I am going to go into the journal part directly. The logic behind this journal part for nowadays CSR, NET and GATE, I asked a very renowned professor. I told my lecture earlier that I don't want to name it here. Very much experienced professor, senior professors from uh, just she got Padma Shri, Padma Bhushan, whatever the award. Why the people are asking from the CSIT nowadays from the journal? Then he asked that. So nowadays it is very much competitive. They want to see you whether you are quite uh, rational to the research or not. That the research means you have to search some journal. You are quite habituated these kind of things or not. For that they are asking the question from journal. So more or less what I am showing you, it will be quite more or less common because there are many common questions from my previous classes in CS and net. So we know that this is the backbone that we can get R1 and R2. Let's say here we have the lithiation. Now if I add here one fluorinating agent, this part is not book coverage, but if the questions comes, then what will happen? Very simple, straightforward, fluorine will be incorporated here. Then we have to know that which is the things that can act as a fluorinating agent. These are the things that can act as a fluorinating agent. This is Na plus BF4 minus. This is number 1. This is number 2. It can be NF Me methyl BF4 minus. And number 3 is this one. F sorry, this is N is here. So this is definitely is going to a plus. Plus this is Cl. This is Cl and BF4 minus. So if the reaction is asked in such a way, for example, this is given, this is lithiated salt R1, this is R2, you apply either 1 or 2 or 3. So you will have a fluoro derivative R1, R2, F. So students, so just have patience and have a look on the last of the lecture. You will realize that this complex reaction just will be turned into your most easiest one reaction ever in your life. So just wait with patience and just hold your attention. Okay, so if you are interested, then this is a very interesting article, 10.2021 recent paper 2021. It's organic letter 401637N. So there it has been taken. Okay. And in some later class, I will show you the journal reference and I will show you the question from CSR net. Then I will correlate these two. That okay, this question paper question has been taken from this journal. Later I will show you. Then why I am emphasizing on journal part. Okay, so let's have example from this part. This is double bond N, NH. Now I am not writing the structure. SL. So we have to use two equivalent butyl lithium. Then it's a Shapiro conditions. It is these sides. So this will be deprotonated. Sorry, this is let's say H. Just I have by mistake write it. N minus SL and this is now minus. Okay, so it's basically like that. Double bond is here and here we have plications. Okay, and we have pH group is here. Just if I forget to write that, so count as a minor mistake and you add in your own way. So this is the reagent. So I have taken this example so that you can habituate with the reagent pool. H double bond O N F. I am not discussing here, it will take time why it is fluorinating. It's a fluorinating agent, so it will be here fluoro derivative. pH So this is double bond and this is the F. So this is very star marks questions. It is not in book. There's a huge probability to come these questions directly in the exam. So this is another aspect of Shapiro reactions. Now the next example, just now it is just already just it is tucked into your mind that if it is Shapiro, then what can be? As I told, now let's say it's a carbonyl is given, then this reaction has been given. TS, NH, NH2. We know that this will be a hydrogen complex, not complex, hydrogen. So double bond N. Now you will not write this structure because this methyl group will just provide a steric interaction to this NH that it will be outside, not inside. I have explained earlier. If this is the fact, now if I use two equivalent butyl lithium, so this is double bond N, this is N minus, and you have stuck into your mind, so this is the negative one because the dip potential from the same side, and we have the methyl group here. And the result, what we are getting, here they have used methyl lithium. Methyl lithium is also a base. So now we have these things. This is lithium, and this one N, sorry, uh, not this one N. So this will be the lithium will be here. It's strongly written. So today my goal is that I will knock two so-called tough reaction, which is going to be a routinely easy reaction for you. Okay. Now you add something. You can add, for example, some protic solvent. If you add some protic solvent, already ethanol is given, so this is going to be this one, and this, this one. So this is minor, only 2%, and this is 95.8%. See, a more substituted alkene, which is quite respectively stable, is going to produce 2%. The less substituted alkene is going to be 90%. That's the beauty of these reactions. Okay, so it is taken from the book. You no need to read this book. Now later you can, if you wish, you can read it. It's a comprehensive organic chemistry. Second edition, 2014. It's Elsevier book. Yeah. So now you are at a point that you have got this reaction very easily. Now come to the point of CSIT net question. What they ask. So after your understanding is clear, now see this is the CSIT net question, which is going to solve less than 1 minute. N, definitely NH will be outside. This is TS. So they have used N-butyl lithium and DMF. Region number 2, region number 1, CSIR net 2016. Now, before writing me, you have done the answer. What may be the product? So we know that it's a hydrogen. So definitely we will have lithium here. So this is the lithium. Second dip protonation from this side. So we have double bond here. It's normal frame. We know that it will be as a result. So let's give a DMF. I'm writing it here. In N-dimethyl formamide, we know that it's a formylation agent. So, lithium plus, this is minus. This minus is going to attack this carbonyl carbon and rest of the things. So formal group will be introduced here. As a result, we are going to get this one with CHO. So it's a 4 marks question of CSIR net, but see, we are solving it in one line. Okay, so I showed you one question came from GATE, one question came from CSIT nets from the same topic. So definitely, so this is important one. Now you can understand it. Okay, so another variety of reaction I'm going to show. Let's show it another page in the same substrate. So this is NH TS. Okay, so this is what? This is alpha beta unsaturated hydrazone. Yeah, alpha beta unsaturated hydrazone. So you have read Shapiro reaction a lot, so you are happy with these confirmations. But in the exam, you see that you are expecting that they will give you some base. If they will give you some base, you will deprotonate here, just add the electrophile. But rather, they are asking it has been treated with NaBH4. They have treated with a reducing agent. Then what will you do in acetic acid? We know that NaBH4, okay, provide the hydride. So hydride will be provided to both, because you know that if you have a double bond, that is going to be reduced by NaBH4. So it will just hydride supply hydride here. This is hydride that comes from NaBH4, and this is another hydride that comes from NaBH4. Now this is ready. PS. Then what? It is done. The next step is that it will go off. As it's a labile NH bonds, you have a good nucleophile, sorry, good leaving group, it will break. That's the logic. Not only that, there are many logics, but I'm not going to discuss right now. This is now double bond N, and we have this hydrogen here. Okay. So we have this double bond. I'm going to rewrite this structure. This is definitely N minus. Okay, so now this will be NH. I'm going to rewrite this structure as like this. This is N double bond N in H. This is the double bond. Just I will show what is happening. You don't need to worry these things. This is coming here, this is here, and this is leaving. As a result, what we are getting. So double bond shift by one carbon. Hydrogen is here, and this is the things. Look, so this is the hydrogen, that new addition to this double bonds. This hydrogen of what? This is the hydrogen of this NH. This one, these hydrogens comes here. So you understand. So this is the things is going to be there. So it is, look, this is 1, 2, 3, 4, 5. This is the 1,5 migration of hydride. Migration. That is, if we reduce this, we are going to get this one and shift by one double bond. And if H is there. Okay. And if it is D, then you will get D here. That's why this is the twist is here. So directly, so if I write it in one line, double bond N, NH, and this is TS. Let's reduce it by NaBH4. Our acetic acid, SUH, we are going to get shift by one carbon, and this is the hydrogen here. It's very valuable questions. Though these questions didn't appear any year, but might, there's a possibilities to come this years. Okay, now we are quite habituated and not quite habituated. Whatever the question, if the question is given from Shapiro reaction, whoever is following the class, definitely you secure your 4 marks. If the questions come, this cannot be excited around these examples. Almost I have covered 360-degree angle. There are many examples that falls in the same category. Now I'll go to the Julia olefination reaction. This is another important reaction. As we are making C double bond C, we are just taking the example of the same reactions. It's about Julia olefinations. So if I today you have take the class on Julia olefination just for 2 hours, it will be finished. So I will make it quite shorter. Just I will let you to understand the reaction in details. Then I will show you the example I have shown you. So what is the substrate? This is the substrate. S double bond O, S double bond O, AR, aryl sulfonamide, hydrogen, and this is R. So if I treat these molecules with a base, let's say butyl lithium, then what will happen? Butyl minus will abstract this proton because this is acidic proton. Why this is acidic? You all know that. Because this negative has a delocalized friendly environment around itself. So that's why it is stable. This is AR. Then what will happen? Now if I treat with an aldehyde, double bond O, R, let's say it is R dash H. So this is going to attack here and this will be O minus. So what am I getting? R. Now this is, I write just SO2 AR. Here this C, O minus, H, R dash. Then for reaction purpose, we have to quench this O minus. Quench means we have to just make it neutral. Then how we can do that? By treating with acetic anhydride. I am again telling I am doing this learning part as well as the tricks, but I don't believe in tricks part. So that's why I am showing you the every details of these reactions. So it is also just I'm trying to just show you the bit of the organic chemistry. So we have to quench this O minus. That's why it is for reaction purposes. So that you understand everyone. So if sometimes the quencher changes, you might think that is a different reaction, but this is not. If you understand the reactions. So now it is OAC. Means I write now acetyl group at AC. Here we have SO2AR. Now it is R dashed R. So if you treat this with electron transfer agent, sodium amalgam, it's transfer electron, then what will happen? It's a single electron transfer. Single electron transfer. It is now OAC R dashed dot R. It will leave plus another NaHg. So it's now 2 electron transfer. R, we have OAC, we have R dashed, and this is going to leave. As a result, we are getting R dashed. In previous reaction, we find that mostly Z alkene produced. Here you are showing that E alkene produced. This is the E alkene. So here you have to, when the examiner will supply the questions, you have to careful in 3 positions. One is the attack on these things. This is number 1. And number 2, the quencher. Definitely you have given a quencher, that is the acetic anhydride. If you get 2 things, means it is going to be the Julia olefinations. I hope you have understood this mechanism. Very easy mechanism. Just practicing 3-4 times enough for that. Now I am directly coming to the example pool part. This is the first example I am showing you. We know the core of this reaction. Now how the substituent are being played in the varieties part. So that's why I show the first right of these reactions. Let's say this is our starting substrate. This is S and pH. Just try with butyl lithium. So we are chemists, we have to be technically correct. We have to use dry THF and cold temperature. Sometimes cold is okay, sometimes we have new to minus 78 degree. And this is SPH. So this is the deprotonation is here. If deprotonation is here, next I told that I have to provide one aldehyde group. So this is the aldehyde group, CH3, C double bond OH. Now this will attack here, and this is going to be O minus. So in book, you will not find the mechanistic part that I am doing. So let's, here now it is SPH. So this is the new carbon-carbon bond. So this is that bond, CH. This is O minus, CH3. So you have to neutralize this part. Otherwise, it will not live. It is already negative, so it will never live. That's why you have to neutralize this part. So those who are quite good in organic chemistry, they can follow my language, which kind of language I'm using, which kind of making I'm trying to as interesting as possible. And those who are quite weaker, but just have some basic chemistry, will be happy to do these things, because this is a very detailed one. This is not given in Carothers, it is from directly journal. Okay, so as I told, you have to just make it neutral one. So in the solvent conditions, it will be OH. So just here I just need a protection, it will be OH. Then you have to use MCPBA. MCPBA. It's a oxidizing agent. What will do? It will oxidize the sulfur pH, and now we have CH, OH, these things, CH3. As I told, this is not a good living group. You have to make it a good living group. Then what we are doing, we have to use a base that will deproton this OH. For this reaction, we use this base. This is called DMAP. You can ask, sir, why you are using a lot of reagent? Because sometimes it's a base, you might treat as a reagent. That's why just DMAP is a base. This kind of information should have in your mind. We are using acetic anhydride. If we use a base and acetic anhydride, this is going to be acetylated product. Now it is now protected OAC. That is now, in another words, you can say now it is the AC of cow. Then you can play with these things. Just add sodium amalgam. So it will be electron transfer here, 2 electron transfer. So 2 times. So let's again writing sodium amalgam. So we'll get 2 electron transfer. So this is CHOAC, and here we have, let's say, this group CH3. This is minus, OS is going to leave. As a result, we have this double bond, this one. As simple as that. This is only olefinations. And just for your belief part, it is from taken this one. CSIT is a good journal, 2004, 6. So during the writing the book of Carothers, for the reference the author used, I am trying to cover as that reference, and what the reference the author left in order to restrict the volume that book, I am adding that reference. So it is, that is the total things. So in the whole pool of reaction, Carothers and the Cole have used some reference. They have left something. Then I have added that left part also, so that it become totally good for us. Okay, so let's do another things. Just now I am practicing. It is done. Just I am showing you example pool. This is methyl. This is SO2 pH. If you add one base, you are habituated. You know what will happen. This will be SO2 pH. This is negative. Now you are look for aldehyde. I am providing that aldehyde. C double bond OH. This is the aldehyde. So now you know that it will attack here. It will go minus. Then what you have? You have these things. Me SO2PH, we will have a CC bond, we have this CC bond, it will be CH and OH. Now we have the rest of the family, these things, Me. You know that you have to make it a good living group. So if you think that only acetic anhydride is that is used to protect these things, here I am showing the another new thing, MESO2Cl. Okay, that is also used to protect this one. So as a result, what will happen? It will be these things. If I write some carbon more or less, just you correct it in your notebook. SO2, Me, and SO2PH. Then again, it is the S of cow. It is everything is ready. Just to use sodium amalgam. So it will be cleaved. Cleave means not cleave, it will have a double bond here. So this is the product we are going to get by Julia Olefinations. Okay. So this is given in the book of Carothers. This one is taken from Carothers. And here, next example also I am showing from Carothers. If I just show you these examples, once you read that book, it will be easier for you. That's why I am using a lot of example pool. Just I am writing the whole thing. Why? Because you have to know where should I look and which thing should I left. I shouldn't look all the part here. This is C double bond OH is here, and it is given this sulfonamide. So it is SO2PH, and it is very interesting example. Okay, let us say. So if I use a base, butyl lithium, dry THF, and minus 70 degrees centigrade. Okay, then what will happen now? You know that at this condition, it will be negative. So it will attack here. As a result, what we are going to get? We have this ring O BZ. This one is here. Now this is C. This is O minus 8. We have new bond SO2PH and these things. Now you need to acetylate it. So it is given a acetylation reagent. Okay. So there, if we use here AC2O, now it is going to be OAC. Now use sodium amalgam. It's going to get these BZ. This is CH double bond CH. Here, these things transalkyl. The trans. Okay. Now I have shown you two quencher. One is acetic anhydride. Another is I show you it is Me SO2Cl. The third example for you to show the quencher. Sometimes it changes the quencher, so you should not be frightened seeing the different quencher. Let's say again, just I am doing the code one. You should not be frightened seeing these things. Let's say it is yeah, O C double bond O pH. Already it is decoded with that. And okay, I will show this example later. Now it will be complicated to show you this. Let's take it examples. directly from Claydon what he used. So this is the example I'm going to show you from Claydon. So I am not bothering about these things. This is O C double bond O pH and SO2 pH. If it is given sodium amalgam methanol, see already this is ready. My sulfur, everything is ready. We no need to go on. So it is direct examples. Just I put a double bond here, nothing else. That's why I gave you the easier examples. This one. So for the Julia olefination, you know that no need to that you will be given aldehyde, you will be given this kind of things. No, it is direct in the ready substrate. Ready substrate. So your goal is if I do the frame, let's say this one the frame. So here you will have H double bond O, H double bond O pH, this group. Here you will have leaving group. Leaving group. That leaving group may be given directly. What kind of thing that means? That can be OAC, that can be what I showed is Me SO2, that can be this one, that is O C double bond O pH, this kind of thing. It is nothing but the quenching by, let's say I have O minus instead of acetic anhydride. I'm sorry that I have to go longer, but I have to finish this topic. This is benzyl chloride. So if the quenching is done by benzyl chloride, then we'll have these things. O C double bond O pH. So if we have this frame, that is the Julia olefination frame. There you just use reduction by sodium amalgam. You will have this alkene framework. Either the question will be given directly or they will ask to construct this framework. But this question will definitely come from this topic. So it is given in Claydon book, but topic is more elaborately written in Carothers. So read it first. Okay. Then I don't know I should go or not, but I have something to show you again. Okay. So let's show you just one of the examples that after that I will finish this class. It's too much longer with this kind of hardcore organic topic. Okay, if it is given, just think as a practice set. Let SO2 pH, add butyl lithium. Now I will not show you the mechanism. Many times we have done that. THF and minus 78 degrees centigrade. Then we'll use aldehyde. OAC, this aldehyde is given. Then we'll see the quencher. AC2O. See, all these three are given. So these are on the format of Julia olefination. So what will be the framework? Now I am doing these sides. This one, these things. We have SO2 pH is here. pH. So here we'll have now aldehyde new bond because this minus will attack here. If this attack here, oh sorry, just I have make one carbon shorter. Yeah, so this is that thing. This side, so this is the reacting side. This side is nothing but this side, this one. So from here the decimal attack. So here CH as CH, this will be O minus, and that O minus will capture OAC. So it is OAC now, and this is the given part. Now again same thing that of the Julia olefination. Now you look. So this will not be in this format. So this will rotate round. because of steric purposes, because these two groups have to be antipositions. If they rotate round, so that what we are going to get? Yes, this is the things, and now OS will come and SO2 pH. So here, after reduction, sodium amalgam, it will be this double bond, this one and this one. That is the things I am going to convey. We are getting trans alkene. Okay, and just you be present. So if you are just quite devoid of concentrations, no, don't worry, just you may not listen it, but later once this video will be uploaded to YouTube, what you can do is you can see later sometime, just last 10 minutes, let's have a look what I have told, that part we can go on. So if you understand, it's okay. Even if you don't understand, that is also okay, no problem with that, but let us see it from the YouTube part, because this is nice example. So this is the example I'm going to show. The student make a blunder mistake, I'll show the mistake point, and then you can correct the mistake one. So here it's a modified Julia olefinations, double bond O. So this is the substrate, direct aldehyde, and so this is N. Just see the examples, no need to memorize anything. I will not show you the mechanism for these things. Later I can OBN, just do not count down the carbon. So here if I use NaHMDS, these are base, if I use base, this minus will attack here. As a result, we know that at this position we have a one double bond in transpositions. Look, so I am doing one double bond in transpositions. Now I will show that a blunder mistake point by the students here. So it is the transpositions, nothing wrong. You know that in Julia transposition, then what's the point of mistake? That I am always asking. Let's think the number of carbon is here same. Look, OBN. Here it is given these fashions. Now they will make another conformations. We like that. This is the mistake catching point. Trans double bond. Let's say number of carbon same, don't count that, and it is given at this. So what we can do, not this is OBN. So maybe you know that there is a trans double bond, you are happy with that, your stereochemistry is matching, it is matching, you will go for these options, but this is wrong option, this is not. Why? You look at this OBN, this is upside. So they have made this OBN downside. It means the same molecule just make a rotation about this bond to puzzled. If it is rotated around this bond, this is going to come down. That is, this is the answer, because this is and that is the same thing. So this is the mistake catching. So once you are confused with the stereochemistry, that you can never find that it never supposed to go below reactions, so you will be confused. Then why it is below reaction? Something is wrong. Then have a look this end, this one and that one. It's a generalized tricks. If these two ends are different, means that this is the same thing. It's equivalent to upsides. So this is going to the answer one. I think you have got my point what I am trying to say. So if this OBN was in this direction, let's say it is the OBN, then this group have to be here in upsides. So they have make it downside here and OBN downside. That's why this is a very interesting error catching point for the stereochemistry. Error catching point. In stereochemistry. So do not do this error. If you are puzzled with stereochemistry, look the end of the product. If it is same directions, then it is okay. If it is opposite directions, then what you are thinking, that is right. Okay. So that is quite interesting. So this is the paper directly from Julia. Tetrahedron. So later you qualify the CSIT, NET, get whatever you want. In near future, if you come with organic chemistry, if you love the subject from your heart, then read these references, because this is the work directly done by the scientist upon which the reaction is named. So this is the paper from Julia and his student Kusinski. Julia and Kusinski. Okay, it's a written letter. You can read it later. Just this example. By this I will finish. Again, I told if somebody want, they can.